Hi, I'm Maggie.
And I'm Lauren.
And I'm Paige.
And I'm Mary.
And we're going to talk about ocean currents.
As we all know, there are two types of ocean currents: surface currents and deep ocean currents. Surface currents are affected mainly by wind, and they can affect the water to a depth of several hundred meters. They move in a circular motion due to the Coriolis effect.
It also affects climate. It warms or cools the air above it, influencing the climate of the land near the coast. Deep ocean currents are affected by differences in density, which is also affected by temperatures and salinity. So the warm surface currents end up going to the poles, it gets colder, which means the temperatures decrease, the salinities increase, and it becomes denser, which causes it to sink. So this demonstration shows how cold water is denser than hot water. And as you can see, the cold water is denser because the molecules are more packed together, whereas in hot water, the molecules are more spaced out.
Okay, to start, this is a whole container of water with 50 milligrams of salt in it, dissolved, room temperature. Now we're going to pour salt into hot and cold water and mix them together. It might take a little bit longer for the cold to dissolve because salt dissolves easier in hot water. Okay.
Right.
So now we're going to show you when we pour both of them in opposite sides
At the same time,
which has more density. So here we go. That's coldest side. As you can see, the blue is going under the cold water. This shows that
blue is going under the hot water.
Yeah, red water. So this shows that cold water is more dense than hot water.
Simply because the cold water will then flow back along the ocean floor to return to the equator.
The two different currents can be combined in a certain way called thermohaline circulation. It moves water between the deeper part of the ocean and the surface part of the ocean. It is caused by differences in temperature and density.
So deep ocean currents kind of act like convections. The hotter, less dense water gets colder in the poles and sinks. Then when it gets to a warmer spot, it rises, gets colder, and denser.
Yes, and it is all driven by gravity. It also results in the transfer of heat.
This is a picture of convection. As you can see, the heat causes the hot water to rise, and as it rises, it eventually gets cold and it falls back down, and it's a continual motion.
Another cause of currents is the Coriolis effect.
The Coriolis effect is the cause of Earth's rotation on the paths of the winds and currents. In the northern hemisphere, currents curve to the right, or clockwise, while in the southern hemisphere, currents curve to the left, or counterclockwise.
If Earth were standing still, the winds and currents would move in straight lines.
The global conveyor belt is a constantly moving system of deep ocean circulation, driven by temperature and salinity.
It moves cold, salty, nutrient-rich water of the Arctic and Antarctic to the warmer waters of the tropical ocean.
So basically, it's known as thermohaline circulation, which we already discussed. This is the global conveyor belt.
As you can see, the red is warm, shallow currents, and the blue is deep, cold currents. You can see how they move around the world.
Climate is the weather condition of a region, such as temperature, air pressure, humidity, precipitation, sunshine, cloudiness, and winds throughout the year, averaged over a series of years.
Currents move warm and cold water around the globe. Depending on the current's climate, it can make coastal climates cooler or warmer. Another important term is continental deflection. Currents in the ocean are deflected by continents, which tend to change the direction of the current.
Another term is downwelling, which is a downward current of surface water in the ocean, usually caused by differences in density of seawater.
And then another term is upwelling. It's the process of which warm, less dense surface water is drawn away from along a shore by offshore currents. Then it is replaced by cold, deeper water brought up from the subsurface.
So here we have an example of continental deflection. As you can see, when the water hits South America, it deflects the current into another direction.
So this is upwelling driven by the wind, and as you can see, the wind is coming from offshore, making the cold water come up and then go along the surface and becomes warm water because of the sun.
This is downwelling, driven by wind. As you can see, the wind is heading this way, and the warm water also heads that way, but it eventually sinks down into becomes cold water.